think. Okay, yeah. Yay, we're recording. So Sophia says, you don't have to put a semicolon after every statement. That's nice. And Justin says, the simplicity compared to other languages. That's also cool. Okay. Okay. I hope everyone else, put something in the chat, but I guess we'll keep on going. So to everyone that's in this class, we're not using an IDE for this class, like you may for like intro to Python. I just find it a lot easier to just like set up like no dependencies or anything. So what we're going to use here is what's called the Google Colab. And it's essentially like a Jupyter notebook that runs on the cloud. You should be able to get to this by going to the Google Classroom. That's where you got like the Zoom link and the meeting password. And in, under like the week 1 basics topic, you should be able to see this Python basics. And this is the in-class assignment. Yeah. So if you can, I hope everyone can get to that. So we'll be using that. But if you can't access it, it's totally fine if you just use an IDE and follow along. Cool. Okay. Let's. Okay. Cool. And so if you have any questions, just put them in chat, and I guess we'll get started. So for this class, we're gonna, essentially what we want to do is we want to, this class, we want to make sure that you have all the basics run down. So sorry about that. So we're gonna make sure we have everyone has the basics, and everyone's on the same page. So if you need, I know some of you don't have a lot of experience in Python, but that's okay. We'll try to get you up to speed. It's not super hard. So I think like building off what people said before. So these are kind of some of the basics. So Python is a scripted language, and it's a generalized like programming language used for data science. And some of its strengths are its readability and its simplicity, which makes it really easy for like beginners to learn like what they have to do. And if we go directly into some things that you should know, that you can print words and other variables with the print statement, and you can use like types to identify the type of the variable. So if we go to our Colab, I'll teach you how to use these. But so you can see that it's just like a bunch of like cells. There are like text cells, and there are like code cells. So you can see here, like text cells have explanations, while code cells are like things that you run. So if you want to run a code cell, you place your cursor like anywhere inside the coding thing. So like in here, and then you press like the what's it called? Like the run cell or the triangle. So if we like press this, it should run all of these things. Yeah, it does. So similar to like a really easy, like Python editor, we can just like run like these commands in like the console. And so these things kind of build on top of each other. So if we see right here, if you run a piece of code and it gives an error, the most likely error is that you didn't run something before it. So that means that that's why you might like get like trace specs and you don't understand why. Or you simply just like had bad syntax and that's why like you might have an error. So if we look at the print statement, I hope everyone understands what this is. Essentially, like you can print things to the console. It's like you can print a string, or you can print like bigger strings. You can do like print integers, so you can do operations inside of it, or you can print like lists, and it'll come out as like a list. So like this is for you to try. You can like go into here and like edit it. So this is like totally interactive. Like you change this around and like say, like print your name. So my name is Ish Furlango and I'm 18 years old. And I just want to make sure that everyone can like do this. So, and for those who are new, who just came in, this document is in your is in the Google Classroom under week 1, under the week 1 topic. Just want to make sure that everyone can. Okay. Any questions? I feel like that's kind of pretty self-explanatory. That's, yeah. So usually during classes, we'll have like a warm-up, and this will be like, this is kind of our warm-up since it's a review and we're not really doing any new content, but usually we'll have a review of the previous class, and that's what we're doing, like a review of Python. So this time, that's what we're doing. The next thing you should know are comments. So like we have like the hashtag or #, and those indicate like comments in your code. And so, yeah, if you want to like add like important, if you want to add important things to your work, or like add important tidbits to help other people read, then yeah. So here we can see this, like you can try, and you know, if you run this, it'll fail, right? It'll be like, what does it want here? Like invalid syntax, because this doesn't really mean anything to Python, but you can like comment it out really easily. So I'm in a Mac right now. So what I do is command / and it'll automatically like take all those pieces of code and like highlight it for you. But if you're on like a Windows machine or Linux, if you do like control / like it says here, you should be able to like see that. And if you run it again, it should be fine. Any questions on that? I feel like that's also pretty easy. Oh, okay. I think that's, sorry if I mispronounced your name. Is that Amelise? Sorry. I think, okay. Is that right?
Yep.
Oh, okay. If you go to our Google Classroom, there's a page in there, or in the week 1 topics. It's a Google Colab. It's in, I can show you. It's like right here. But this is what I see. But hopefully you see the same thing. But there's a thing right here. It says Python Basics Intro to ML in Class Assignment. And if you click on that, you should get a Google Colab. And that's essentially like what we'll be using in this class to run Python code. So yeah. And so we went over printing and we just did comments. Next are variables. So variables in Python are dynamically typed. So you don't have to provide a type to each of your Python variables. So like this could be anything really. Like a string, a number, or like a list or tuple, but doesn't you can just change that on your whim. And so this is one of the things that that Colab does, is that you can like run a here, and it'll store that in like its RAM, and then in a completely different cell, you can print it out down here, kind of like a Jupyter notebook, which it is. Okay. I hope everyone files in by now. So hopefully. Okay. And so you can like try this yourself, make your own variables and printing them out. So like I'll do. Will I be able to zoom out? Yes. I don't know if I can. Like that. Like that. Is that okay? Okay. And then there are types. Like obviously there's like integer, string, list, all those things. And you can find those out by like finding the type of those. So you can like, there's like a thing right there. But you can like find all of them as you want, as you wish. And so if you would like, there's like a statement right here. Try to find out what the type of I is. Just like down there, like in here. Nope, not. Cool, okay. So you just like do this type I. And it's a tuple. That's what that is. And then you can convert between types. So like this will convert A into G. This convert, okay, whatever. It's str. But whatever, not bad. And so not all type conversions work. Obviously, like you can't convert this list into an integer.
What is a tuple?
Oh, okay. So a tuple is like, it's a list, but you can't change any of the values inside of it.
Oh, okay.
But you can like, if you're in Java, the term is called immutable. So it's an immutable list. You can like get information out of it, but you can't change what's inside of it.
Okay. But will you be able to give us an example of we can do that?
Sure. It's like this. I guess we can do it in here, but it's like if you can print out like I of 0, but you can't say I of 0 equals like 3 now. So So you can see that it printed out 1, which is the first, the index, but you can't like change what's at that thing. And so you can even see here, like tuples don't support item assignment, which means that you can't change the value.
Okay.
Yeah.
Thank you.
Welcome. So we'll keep on going. Yeah. Then there's if else statements. These are also like, basic Python stuff. If you want a condition to be met and then something to be run, you'd use these. So like if condition here, if this is true, then we'll run statement 1 and statement 2. Otherwise, we'll run statement 3. And so, yeah, if we have multiple conditions we want to satisfy, so like, let's say we want condition 1 and condition 2 to be true to run it, we'd use like the and statement. So that's what we do down here. Like if condition 1 and condition 2 are true, then we print out that both conditions are satisfied. So let's see how it works. The or is if only one of these conditions needs to be true. So, so since condition 2 is true, this will be printed. So those are like kind of the basic operators. Then beyond that, like there's equality and comparison. And sorry, I'm going really fast, but we kind of have to, since this should all be review for most of you. There's like equals with the double equal sign, not equals with the exclamation point equal sign. You've got greater than, less than, greater than, equal to, or no, less than or equal to, or greater than equal to. So those are like, those should be, if you're coming from Java, those should be very, you should be able to identify those. Something that's a little different though is the is operator, which is used to check whether two variables refer to the same object. So like we can look down here, like is not the same as equality. If we look down here, if you run this, it'll say that, A and B are the same, right? So like there's lettuce, spinach, Brussels sprouts, but they aren't the same object, which is why if you say A is B, it'll print out false since they aren't referring to the same object. Does anyone know why you might use is over like equality? No, type it in chat or something. Okay. Okay. I think the only reason why you might want to use one of these is if you're like checking for null, since I think like null, if you check for nulls, it's like the same object. So if we run this, it'll show that A is true and A is B is false. And then there's not, which is like similar to the exclamation point operator in other languages. And so this will convert like the true to a false. So not A is false. Awesome. Other things, for loops. So these are used to iterate through objects, which are almost always lists. So like here's a sample list. And so, yeah. So like for value in the sample list, you can print out the value. and that'll print out A, B, C, D. And you can iterate through, it's not only just lists. So you can iterate through like this string. So that's my name right there. And so you can like print out each character as well. It's like lists, strings, you can iterate through each of those. And so there's a question for you guys down there. Type in chat when you're ready, but like say like you did it, and that'll be cool. Like if you do this question down here. Or does anyone want to share what they did? I guess that's the better question. Okay, I'll do it myself. So essentially, I think what you'd want to do here is you would want to convert value to an integer first, so or a string. So like what we did back here. So like you do for, I don't know, I in string value, and then you could print out I with that. I think that's the easiest way. But you could also like do it mathematically and divide by 10 every time. Like do that thing. Like you divide, take the modulus of 10 and then divide by 10. And that's how you do it. Another important thing, there's the range function. So like it's used to loop through like code a specified amount of times, and starts at 0 and then increments by 1 until it ends. So like here, this will print out from 0 to 9 right there. And you can, it starts at 0, but you can change that. So if you do like 3 to 10, now it'll start at 3 and end at 9. So cool stuff. This is weird. Okay, that's weird. Let's see. And then if you want to do like customized strings that change based on variables, there's like things called replacement fields. So like these, it'll replace these brackets with like the strings or numbers in the format. So if you run this, like the introduction will print. You print introduction. It'll like put H for an 18 in there. You can try that out with your own thing. Cool. Okay. And then there are functions. These are also simple. You have like, they're reusable pieces of code, and you define a function like this. There's like the def keyword, the function name, and then the parameters inside that function. And then you put a colon, and then on the indented line afterwards, you put like the stuff to run. So like here's a function that we define as operation. It takes an x and returns the square root of x plus 1. And so we can call this by saying operation, I don't know, what's a good square root? 15. Okay. That's kind of mean. Whatever. I don't know. X plus 1. Wait, we can do x like that. That should probably work. So, yeah. So 15 squared is 225. If anything, you guys know I wrote this because there's so many bugs in it. Okay. And then there are lists. Hopefully you guys see this. So like there's, to create a list, you can use like the square brackets. So that's, you can like print out, that's you make a list. And if you want to find the value at a specific index, you'd put the list name and then the index inside the square brackets. And so list indices start at 0 and they end at the length of the list minus 1. So could anyone tell me like how you might print out Jose in this list? Like in chat or in or out loud. Yeah, okay, cool. So if you print out like student, oh, not in chat. So you print out like student list 1, prints out Jose, yay. And then slicing is how you retrieve multiple values from a list. So as this shows down here, if you slice using the colon, you can get the first and the second value through this one operation.
They considered the first value.
Can you say that again? Like,
Why is Jose considered the first value?
Maria is considered the first value, and then Jose is the second one.
Oh,
So
why? Yeah.
Oh, for this one, okay.
Yeah.
So list indices start at 0. So if you do,
Okay.
so student list of 0 is like the first one, and then 1 is the second one. It's a little confusing, but and this is like similar to a lot of like programming languages where the first like index is 0, not 1. You can see that Maria and Jose are right there. Next question.
Thank you.
Yeah. And so when we do slices, we can see that when we do 0 to 2, we don't get 3 values, but we get 2. So we get 0 and 1, but we don't get 2. So it's like 0, 1, and not including 2. This is similar to like the range function that we did all the way up here, where it includes like the first value give it, but not like the ending value. And if you want like the explanation for that, it's that like range of 10 will give you 10 elements and not 11, which is probably what you don't want. If you do like, if you start from 0, especially. So yeah. Okay. And then this is like kind of the end, but there are a couple like one line like things that are really helpful. So like if you want like a one-line if statement, there it looks like this. It's called a ternary, I think, kind of, but it's like you have the variable and then the value if it's true, if the conditional, else the value false. So you can try making your own. I'll write my own, like, so we'll say, this is true if like 5 is greater than 4, else this is false. And if you print A, you'll see that, hey, this is true. So yeah. Okay. Anyone have any questions on this? Since we kind of read it out, it's kind of readable. So yeah. Like this is true if 5 is greater than 4, else this is false. Okay. And then there are one-line for loops. So like this is like what you try to do if you wanted to kind of make a list from another list. So like this specific like one-line for loop, actually I don't know if this would work, but it should take the square root if you run it. But it should take the square root of 0 to 19. And then a lambda is like an anonymous function. So you can like assign a function to a variable and then run it like that. A square root would work, which is unfortunate. So yeah, that should be everything for this class. We missed some things, obviously. So there's other parts to Python. Obviously, there's like dictionaries. We didn't go over tuples, which I don't really think we need to. And then we have like map and enumerate, which are other functions that are built into Python, but we won't necessarily be using those in these classes. So I didn't really go over them. But if you want to, there are tons of resources online for reviewing Python. I can share some after class if you're interested. So yeah. You have homework for this class. I don't know if it's scheduled for 2:30, but I'll make this assignment go live right now for everyone. So this is like your assignment, I guess.
The class is ending right now?
No, it's not.
Okay.
We still have an hour, but I think we can take some time to do some of this in class. So this is like your assignment. It's 5 programming questions that hopefully you all can do. And oh no. Okay. Well, it shows the solution. So don't look at the solution. Don't look at the solutions. I don't know why it's like that. For some reason, like it shows the solutions by default, which I hope it doesn't for you guys. It's like, nope. So try these out. There are 5 questions, and they should be using like your basic knowledge of Python to be able to solve these. And we can take until 11:30. I think. Do we get out of here at 12 or 11:30? Does anyone know?
12.
Okay, yeah. Thanks. So, we can do this independently, or you can do groups. Do you guys want to do groups? Like a vote? I don't know. Anyone want to speak up and say groups or not?
What are we gonna speak? Hold on.
Okay. Actually, okay. We'll test out some things in Zoom. Here, I'll stop screen sharing. Let's see. Can people like raise their hand and say whether they want groups or not? Actually, if you want to do it independently, tell me if you want to do groups, like by raising your hand.
Well, actually, I know that it's a little bit kind of like related, but I was just wondering, like, how do you like select a large like amount of text and then like quote and then like and then
Speak it
comment it
out.
all?
Okay. So if we go, okay, good question. I'll bring it back to our assignment. If we can, you scroll up all the way back to the comment section. It's control or command like slash. It's like right here, if you see right there. So you highlight it, that, and I'm sorry you can't see my keyboard, but it's command slash on my keyboard, but or control slash. Like that. Did you get that? Or
Yeah, I did. Oh, thanks.
okay.
Oh, and I choose to do it independently.
Okay.
Oh wait, so what we're working on in class, this is technically like the homework, right?
Yeah. There's another like assignment after this as well.
I see.
But I think this is the harder one. So we can just like do these in class, and then it's just like review. So and if you need help, just like ask me. There's solutions. So if you really need help, you could look at those. So yeah, it took me so long to write all of these.
Because I don't have access to Google Colab yet. Is it okay if
Oh
you share the screen and I'll
yeah,
like
yeah.
show me the
My
problem?
bad. So yeah. So there's question 1. And come back at 11:30, and we'll finish the class with an intro to machine learning, like you all were promised.
The solutions are posted by default on our screens, or at least for me.
Don't look at those. If you want to
Alright.
like hide them, like double click on
Yeah.
them.
Yeah.
That is my bad. I don't know how to. I don't know how to hide them by default. So
It's
that's
okay.
something I have to learn. I'll bring back the screen in a second. Give me like 5 minutes. Sorry. I just want to make sure, everyone who isn't here is like here, but under a weird name. Is Krishav here? Okay, no Krishav. I think that's Carol, maybe? I think it's your English name. Carol Gong. Okay. Riddhi, I think it's your name. Riddhi, is Riddhi here? Okay, no. And then Julia. Cool. Okay, that's everyone who's not here. Everyone else, I think you've been accounted for.
Oh wait, is there a third question? Oh, I see that there are.
Tell me when you need the fifth one, if you're looking at the screen share. Felix, we still have more class after this. So at 11:30, come back. Don't leave. We still have one more thing. This is just like kind of your in-class assignment. When you're done, put something in chat so I know you're done.
Can you go over question 4?
Yeah, go ahead.
No, I was just asking if you could go over question 4.
Oh, sure. Yeah, that one's a little complex. If you look at the solution, spoilers for anyone, I guess. So we don't really go over this, but so essentially what we do is we split the string using this split like command, and that'll like create a list of the values in the string. So actually easiest to see if I print it out. So first we get, so if we do that, hit runs. So we get like a list of the values in the string, and then we reverse it. So like that'll reverse the string. That. So it's reversed now, which is what we wanted. And then we join it back up into a string. So that's what this join thing command does. I don't really expect you to, I guess I don't really expect you to be able to do this. But it's kind of like practice if you do know. Like it's not, the best way to say this is that it's not imperative for you to know this to understand machine learning. But it does like help you understand the basics of Python, I guess. Kind of list. Yeah. Like string manipulation. Maybe. Does it make sense? that's a, I guess that's, yeah.
So can we submit the collaboratory once you're done?
I think first save it to your own drive and then submit it. So like save it so that you have a copy of it yourself and then submit it.
Okay.
So that if I mess something on my side, you still have your work. Yeah. Okay, come back. If you didn't finish, that's okay. It's due next week. Not for a grade, I guess. I guess it's kind of for a grade. For completion. It's graded for completion. So yeah. There's another assignment as well. So you have 2 assignments due next week. We're not done yet. Don't leave, please. I guess, yeah, we'll get started here. So before we get started, we have to kind of define some things about machine learning, and hopefully this can all go really smoothly. So yeah. Okay. I'll start my video again. Okay. So here's some important terminology. If you would like to, you can like take some notes. yeah, do what you want to remember what these are. Since I'll be using these throughout the entire course, and hopefully you can remember like what they mean, so that we're not all in this confused state. So let's begin. So okay, machine learning. So machine learning, in what we consider its supervised form, which is one we'll be learning in this class, has models learning how to combine inputs to produce useful predictions on never before seen data. And there are 3 things in that statement that are really important. Models, which we'll define. Inputs, which are obviously you know what those are. And then predictions, which are the output. And then never before seen data, I guess. And that's where the strength of machine learning lies. Somewhat similar to like a human brain. It's able to take previous knowledge and use it on new things or new inputs or sensations or data. And this is kind of the baseline of all machine learning as we know it right now. Taking inputs, training, and then using them on data that's never seen before. So I guess we can talk more. So let's talk about our inputs. And these are what we consider our features, or I think the X variable, if you would consider this like a line, like Y equals MX plus B. So a small machine learning algorithm may only use like one feature, while a more complex one can use tens of thousands of features. So for example, if we were predicting house prices, some of these features or inputs could include the number of rooms, maybe the distance to the local like elementary school or middle school, the amount of stories in your house, or maybe like even like something like the phrase hip in marketing. Like if you were like reading you're reading like the house on like I don't know, Zillow, and like its description included the word hip, maybe that's another like feature for your machine learning. So yeah, any questions on that? That's so like features are synonymous with like the input to your machine learning model. And then we have labels. And so these are the things that we're predicting. In our example, this would be the house price, but it could be anything like the type of animal in a picture or the presence of spam in an email. And so this all culminates in this kind of idea that models take in inputs and output labels. And so we have to talk about how it does that. So these are what's called examples. So an example is like an instance of data. It is the combination of a feature and a label. So like a labeled example includes both features and labels. So as the bullet point says, these are used to train our machine learning models. And so in our house price example, these would be the house information with its corresponding home price. And so our model would try to understand the relationships between that house information and the home price. And we'll get into how it does that in later weeks. And an unlabeled example is like the feature, but not the label. And so once we've trained our model, we'll be able to predict the labels of our unlabeled examples. And that's like if we go back to our definition, like an unlabeled example are the never before seen data. If that makes sense. So yeah. Any questions on that? Chat. Okay. And then models. this is like the generalized term for what we'll call like the programs that you make. So
Can
like
you
a
go
machine
back to
learning.
the last slide for a second?
Oh, sorry. Yeah, there's a lot of stuff on it.
Okay, thank you.
Okay. And so these are like the computational relationship between features and labels. And so training, that's like the word or vocabulary term we use for creating our models. And so, so like you show the model, like your labeled examples, and then your machine will gradually learn the relationship between the features and the labels. And then validation, or also called inference, is like the process of using that model on like unlabeled data. And so that's like, if you went into the real world with your machine learning model and started making predictions on house prices, like on random houses that you find, like in your neighborhood maybe. And so that's, okay, I did that really quick. That's for ending early then. But yeah, those are some like vocabulary terms that we should all know. Is that it? Yeah. Oh, last one. So then last thing is classification versus regression. So a classification model, predicts discrete values. So does this picture show a dog, cat, deer, or a fish? Those are like discrete things that classifies. Or does this patient have the disease or not? Those are like if like this or that kind of things. And it puts them into like, yeah, it's like classifying them. Regression is a term you might not have heard of, but it's essentially essentially like predicting a continuous value. So our best example is like the house price. House prices aren't like classified into like specific boxes or like specific labels. They're instead like a continuous like monetary value. Although you could make this classification problem by putting them into, by making labels such as like between 550K and 750K. That would be like its own classification. But if you were predicting like the house price, that would be regression, since you're predicting the value and not necessarily like a classification or a label. Does this make sense? So those are the two like problems. Awkward. So yeah.
Hello?
Hi.
Oh, I thought the class started at like 12. Did I get the time wrong?
Yeah, we started at 10:30.
Okay, when does class end?
We're about to end.
Oh,
Actually,
like,
don't worry. Our this is all recorded, so you don't worry that you missed something. I put the slides in the Google Classroom, and if you want to stay a little bit later, I can get you up to speed. If that's fine with you.
all right. Thank
Okay.
you.
Cool. So that's okay. Those are the, yeah, that's the end. So those are the three, actually that's all the vocab that we'll be using. So to go over it again, machine learning, it's like models combining inputs to make useful predictions. Features are the inputs to your models. Labels are the outputs or the predictions. An example is the combination of, okay, so Tesla's auto drive, is that classification or regressions? That's a really good question. So it's a kind of a combination of both, right? So I think, so if you break up Tesla's auto drive into multiple pieces, that's like, we can describe that, right? So there's the image classification, right? There's that portion. If it's at a stoplight, it has to know whether it's a green or red at the stoplight. And that's a classification problem, right? It falls into two different labels, whether it's green or red. But it's also a regression problem since, let's say that you're on the highway and you're like, what should my speed be at this current moment? And that's a prediction in of itself. Like, should I be going at 50, 51, 52? So those are all like, that's a regression problem there. So it's really a combination of both when you break the problem down into its smaller pieces. And that's where Tesla's auto drive is not one model. It's multiple models working together to make the whole system work. Yeah. So yeah. So models, I think, for the purposes of our learning, models usually can only solve one problem. They're very specified in that manner. So like, it can only be able to like identify dog, cat, deer, or fish. That's like that's like its job in life. But I think now there's some new things where you can predict. There are like models that can do like multiple things at once. So things are changing all the time. But for now, we can think of models or machine learning models as like singular things that solve a singular problem. So yeah. I'll leave you guys to it. We ended like we ended really early. That's okay. This is like a review class or a review session. And I wanted you guys to, I guess, understand the basics before we really dive deeply into this class. Since if you don't understand the foundations and we're starting to like code models, you might be having a really hard time. And I don't want that to happen. So if you have any questions, email me or message me on the Google Classroom. Hopefully you can do that. I think you can do that. But yeah, you have two assignments. There's the problems in Google Classroom. You can do those. And then there should be a quiz / like review of what we learned in class coming in later today. So yeah. You can stay behind or like stay in class if you want to ask me some questions, but at this point, yeah, you're free to go. And this slide and this thing will be, you can all like see it. Like I'll upload it. So yeah.